Hello everyone, hope you are all doing well. So this video is day 3 of the Leetcode crash course that we are solving. So if you are new to this playlist or this channel, I'll tell you briefly what this is all about. So Leetcode has introduced a new interview crash course which contains 60, 70, 80 problems. So what we are doing is it's a paid course, but we will solve all these questions because obviously we know the question names, so why should we pay for it, right? So we can solve it individually, and also I'll be adding some more problems because obviously problem solving 60, 70, 80 problem is not gonna make us a good problem solver, right? So I'll be adding more problems. I've done so in the first couple of days of this playlist, and today also we'll be doing that. Also, the main motive of this playlist will be not to mug up the solutions, rather go into the concept why a particular solution works, and things related to that, right? You don't need to learn the solutions, you just need to understand the concepts and you'll be able to write the code, right? So we have started with linked list. So yeah, this is the day 3 of the linked list related topic that we are covering. So again, today also we have a traditional problem, and the problem says that you need to find a cycle in a linked list, right? So let me just write it. So suppose I have a linked list. Yeah, these are the 5 nodes in my linked list, right? So what does a general linked list look like? It looks like that you have a bunch of nodes and the last node basically points to null, right? This is a general linked list, right? However, this problem says that what if the last node, instead of pointing to null, points to some node, right? Like points to 3 here, right? So this is a loop, right? 3 goes to 4, 4 goes to 5, and then 5 goes to 3. So this is a loop, so, or a cycle. This is a cycle, right? So the problem is that you are given a linked list and you need to find whether you have a cycle in your linked list or not. That's the basic stuff, right? Now in our in our previous videos we have studied a concept related to fast pointer and slow pointer, and we will see why that logic applies here, right? We will not directly apply that slow pointer and fast pointer technique, rather we will first understand a different concept and then we'll come to this problem, right? So just consider that there is a straight line, right? There is a straight line and two people, person 1 and person 2, start basically participate in this race, right? So and suppose the distance to be covered is d. This is the complete distance that needs to be covered, right? So just think, suppose if person p is running at a speed of x and person p2 is running at a distance y is greater than x, right? So what will happen? P1 and P2 are at the same point in the starting, right? At t equals to 0, they are at the same point. At t equals to suppose 10, right? There will be some distance between these two, right? P1 will be somewhat here and P2 will be somewhat here, right? Suppose this distance is d1, right? Now at time t equals to suppose 25, right? What will happen? P2 will be somewhat here and P1 will be somewhat here, right? And the distance will between them will be d2, right? So what I mean to say is that since the speed of P1 and P2 are different, the distance between these two will keep on increasing. The faster one will basically increase the distance from the slower one, right? Why that will happen? Conceptually, that is that is very much obvious. However, mathematically, for a particular time t, the distance covered by P1 will be so just a second. Yeah, P1 covers a distance of, so obviously distance is equal to time into speed, so t into s. Let the speed is x, right? And P2 covers a distance of t into y, and y is obviously greater than x, right? So for time to be same, this time to be same, what will happen? If the, obviously we are considering for the same timestamp, right? So P1 will cover a yeah, this is t, this is t. So what will happen? This is the distance covered by them, right? And if P1 covers a distance d1, so that is d1 by x, and P2 covers a distance of d2 by y, right? And for these two to be equal, since y is greater than x, so d2 has to be greater than d1, right? This has to be greater than d1, right? So that's the main thing. The difference between these two will keep on increasing because this guy is running at a faster pace, right? So this is for a straight line. Now just consider, instead of a straight line, we have a circle, and this is the starting point. P1 starts at a distance of x. So for simplicity, for x and y, just consider that y equals to 2x, because that is a trivial thing that we do, right? And P2 equals to 2x. You can take anything, 2x, 3x, whatever you want, right? Now again, these two start a race, and similar to this, what will happen at time P1, what will happen? P2 will be here and P1 will be here. Suppose the distance between them is d1. Now at time t equals to t2, what will happen? P2 will be here and P1 will be here, right? The distance between them will increase, right? The distance between them will increase because P2 is running at a faster pace. Now since P2 is running at a faster pace, the distance between these two is increasing, right? These two, P1 and P2, is increasing if we consider this distance. However, if this distance is increasing, don't you think this distance is decreasing? This distance, right? And if the circumference of the circle is 2 pi r and this distance is d, right? So if d is increasing, so 2 pi r minus d will decrease. That means this distance will keep on decreasing because it's a circle, right? It's a circle. And if these two are running infinitely in this circle, so that means P2 will meet P1 infinite number of times, right? P2 will meet P1 infinite number of times. P2 will go here, P2 will come here and catch P1, then again move forward. Then after some iterations, again P2 will at any other point meet P1 here and then again move forward, and so on. Again, this is all happening because it's a circle, right? So yeah, I would say this must be clear by now, a pretty obvious thing. That is, if since the distance between these two is increasing, so one part is increasing, second part is decreasing, so the faster one will keep on catching the slower one, right? Now let's come to the linked list part, right? Suppose I have this linked list as I showed you, and then we have a cycle here, right? And we have a cycle. So what happens? This is the head, right? Now just consider we have two pointers. There is a slow pointer and there is a fast pointer. Slow is moving, suppose, like slow is iterating every node or is jumping one step, right? So that means it goes from next to next, something like this. And fast jumps like this, two nodes, and so on, right? So suppose these are the two pointers. Now what will happen if slow and fast start like this? The slow jumps 1 unit and fast jump 2 units. So then if I talk about this loop, then fast will be the first pointer which enters this loop, right? Which enters this loop. This is the starting point of the loop. It enters this loop. Now what fast will do, will keep on iterating this circle, right? This loop. Now after some time, slow will also come and enter this loop, right? Will also come and enter this loop. So now what is happening? Two pointers are running inside this circle with different speeds, and we saw that within a circle, if two people are running at different speeds, then faster one will always catch the slower one from behind, will overtake the slower one and will again catch the fast again the fast will catch the slower one. This will keep on happening, right? So that means slow and fast pointer will meet at some point in the circle because their speed is different, right? Now if at any point of time these two pointers, slow and fast pointer, meet, they both are equal. That means we have a cycle. And that is the way we find whether our linked list has a cycle or not. Now had our linked list been a straight line, that means there was no cycle, what would have happened? There is a slow pointer, there is a fast pointer. Fast pointer would have reached null, right? Because actually in a normal linked list, the last node points to null. However, in case of a cycle, this null is not there, this points to something else, somewhat here, right? So that is why if your fast pointer reaches null, then there is no cycle in your loop. However, if your fast and slow meet at any particular point of time, that means you have a cycle. So this is the basic concept how you check whether you have a cycle in your linked list or not. So I hope this is clear. I'll show you the code as well. Let's come to part 2. Right now, part 2 is, suppose you find that there is a cycle in your linked list, right? Now you need to find the starting point. Suppose this is the meeting, this is the starting point, this is S. Here the loop starts, right? So you need to find which is the node where the loop starts, right? Which is the node where the loop starts. Now just consider that this was the point, suppose or this was the point, suppose this was the point where the slow and the fast pointer met, right? Slow and fast pointer met, let's call it M, the meeting point, right? So what happens what happens here, that forget about the algorithm, let's try to prove it mathematically. What will happen here, right? So suppose slow and fast pointer come, slow jumps 1 unit, fast jumps 2 unit, they meet at this meeting point. Now you need to find somehow the starting point. So now what we can do, so suppose this is a distance, this is distance x, right? This is distance x, that means the number of nodes that we need to jump to reach the starting point, right? This is distance x. Suppose this is distance y, right? And this is distance z. Suppose these are the three things, right? Now what will be the distance traveled by the faster node? We know that the distance traveled by faster node equals to 2 times the distance traveled by the slower node, because for both of them time is same, right? Distance is equal to speed into time, right? So time is same for both of them. Since the speed is a multiple of 2, that means distance of fast equals to 2 times distance of slower one, right? Now what is the distance traveled by the faster node? It will be this x plus some iterations of this whole loop, right? Some iterations of this whole loop. So let's call it n times y plus z, plus, since they are meeting on M, so that means y extra distance, right? This y extra distance, so y equals to 2 times what is the distance traveled by the slower node. Now again it will be same, it will be x plus possible sum of the iterations of this loop, so that can be M, suppose that's a multiple of M, y plus z, plus again this extra distance y, because we need to cover this to reach the meeting point, right? This is the equation. Now let's solve it. If I solve it, so what comes, this x comes here, so that becomes x plus y equals to, this goes there, right? So this becomes n minus m y plus z, right? This is the equation that it becomes, right? Now obviously the number of iterations of the loop traveled by the faster node will be greater than the number of iterations traveled by the slower pointer. So that means n minus m will be a positive integer. Let's write it delta y plus z, right? X plus y equals to y plus z. So that means this x plus y equals to y plus z, right? Delta times y plus z. Now let's take some values of delta. So suppose delta equals to 1. So what does equation becomes? It becomes x plus y equals to y plus z. This cancels, so it becomes x is equal to z, right? That means this x equals to z. What does this mean? That means the distance of the meeting point from the starting node is same, is equal to the distance from the head of the linked list to the starting point, right? What is x? X is the distance from the starting node of the linked list to the starting point of the loop, and z is the distance of the starting point of the loop to the meeting point of these two. That means these two distances are equal. That is what this equation says for delta equals to 1. Let's take delta equals to 2. What does equation becomes? It becomes x plus y equals to 2 times y plus z. That can be written as x equals to, this comes here, I can write it y plus z plus y. Yes, y plus z plus, so x is y plus z plus y. What is y plus z? Y plus z is this loop, right? Y plus is this loop plus y. Sorry, z. It will be z. Sorry, it will be z. yeah, sorry, x equals to y plus z. So that means this x is equals to one iteration of the whole loop, and then this distance z, right? Then this distance z. So it means that if you start the loop here, then you iterate the whole loop and then you travel the extra distance z. So x is basically, what this equation represents is, x is basically x equals to some multiple of this loop, some multiple, probably n iterations of this loop, and this extra distance, right? And this extra distance. So what do we mean by this? We mean by this that if we start, suppose we meet here, and if we start iterating one step from here and from here, from the start of the loop, from head and from the meeting point, right? After we meet, when we start iterating one step, like one pointer moves one step here, one pointer moves one step here, and so on. So what will happen? They both will meet at the starting point, right? They both will meet at the starting point. Why they both will meet? Because the distance traveled by the head, by the first pointer, let's call it pointer 1, and this is pointer 2. So pointer 1 will cover x, pointer 2 will cover some iterations of this loop and distance z, right? After some iterations. So since this pointer is starting from m, you cover some loop, and then you move z distance and you reach the starting point, right? Basic stuff, right? So this means after you meet at this point, just start two pointers. One pointer starts from this point and the second one starts from this point. They both move one step at a point and they meet at the starting point, and then you find the starting point of the loop, right? This is the basic stuff. Now let's come to part 3. That is very I would say just a very small extension of the part 2. That part is, suppose you want to remove loop in your code, right? Suppose you want to remove loop. So what you will do? Basic stuff. At every point of time when you are moving one step ahead, also keep a pointer of the previous node, right? Also keep a pointer of the previous node. Whenever you are doing, suppose p equals to p dot next, p1 equals to p1 dot next, so also do previous equals to p1, right? Do previous equals to p1, then move p1. Now that means, if just I'll make a new diagram. So suppose this is the loop, suppose this is one node and this is second node, like this. What will happen? Suppose p1 is here, so previous will be here, and when p1 moves here, previous comes here. So you know that both the pointers meet here, that this is the starting point. So just to remove the loop, what you do? You do previous dot next equals to null. And now what will happen? This pointer which was pointing to the start of the loop will point to null, and the loop will be removed from your linked list, right? Basic stuff. Now let's jump into the code. I hope these things were clear. Let's jump into the code. So this is the code of finding cycle in a linked list. So as explained, very easy stuff. You first check for boundary conditions, that if head equals to null or head dot next equals to null, then you return false. That means that you don't have a node, or you have just a single node, just return false. Or on line number 17 and 18, you can see I've taken a slow and a fast pointer. On line number 19, you can see what I'm doing. While slow dot next is not equal to null, and fast dot next is not equal to null, and fast dot next is not equal to null. That means slow is jumping one step, fast is jumping two steps, right? What I do on line number 20, I do slow equals to slow dot next, fast is equals to fast dot next. Simple. On line number 22, I check whenever slow and fast become equal, just return true, right? Else, when will we return false? When we come out of this while loop. And when we come out of this while loop, we come out of this while loop whenever fast dot next is equals to null, or fast dot next become equal to null, right? Now any one will become null only when there is no cycle, the last node is pointing to null. That will be the only case, and in that case we won't be having any cycle, so we return false, right? I hope this was clear. Let's move to the second part. Just a second, I had one more problem. Yeah, this one, linked list cycle 2. That was it was saying we need to find where the cycle begins, right? So again we will do the same stuff, right? From the meeting point, we'll we find the meeting point, right? Once we find the meeting point, we start two pointers, one from that meeting point, one from the head of the linked list, and we keep on iterating, and wherever we meet, that is the starting point. So how we do that? On line number 16, you can say we have a fast and we have a fast pointer. So fast is not equal to null and fast dot next equals not equals to null. So this is basically to find the cycle stuff. So you fast move two steps, slow moves two steps. Now on line number 20, fast equals slow. That means we have found the meeting point. Now when we find the meeting point, now we need to start one pointer from head and one pointer from this meeting point. So from line number 21, you can see I have started a slow 2 from head, and now what I am doing, while slow 2 is not equal to slow, now slow is already pointing to meeting point, so no need of new pointer, we can use slow only. So again, see on line number 23 and 24, slow is moving one step, slow dot next is moving one step, right? While these two are not equal, they both are iterating. Now as soon as it becomes equal, we return slow, basic stuff. Or else on line number 29, we return null. That will not be required, however, but still, since you need to return, so that's what I have done. The other way would have been you break the loop and then you return the slow pointer, but yeah, that's a different way of doing it. So yeah, these are the two basic stuff that we do. And again, as I told you, suppose you want to remove cycle from your linked list, then what you do, you keep a previous pointer as well, and you just as soon as you find the starting point of the loop, you just make previous equals to null. That's it, just a couple of extra lines and that problem will be solved. So we discussed three things related to linked list. I hope you enjoyed this about how we get the intuition to solve these type of problems. Also, if you find this video and playlist useful, do subscribe to the channel, do support it by giving up a thumbs up. In case of any queries, please do mention that into the comments. I'll be more than happy to revert on each one of them. And yeah, I'll come with the videos every day. The last day I was not able to make video because of some celebrations related to the Dashera, so there was a lot of noise, background noise, so I was not able to make the video. But yeah, things will be smooth now. Okay, thank you, take care, bye bye.